Hi everyone. This video let's solve Leetcode 167 to sum 2. It's marked as medium. Given a one indexed array of integers and numbers that's already sorted in non-decreasing order, we have to find two numbers such that they add up to a specific target, and index 1 should be less than index 2. So we return the indices of the two numbers, and it's going to be one indexed. And so it's given that there's exactly one solution and we cannot use the same element twice. So let's understand this problem. So it's quite easy to understand. So if you have a array called numbers, it has these elements and our target is 9. So we basically have to return uh, the indices of the elements that add up to 9. Here it's 4 and 5. Since we need to return the indices in a one indexed way. So here if it's zero index, then the index of 4 would have been 2, but since it's one index it's 3, and similarly for 5 the index would be 4. Okay, now there are a couple of ways which we can solve this. The brute force is quite simple. Let me just rewrite the array here again. So 3. So in the brute force method, what we do is just keep an index I here, the index j here, and we essentially add I and j. So this adds up to 4, which is not equal to our target, and then we move j forward. Now 1 plus 4 is not equal to our target. Then we again move j forward. 5 plus 1 is not equal to our target. Keep continuing this. So 8 is not equal to 9. And when we reach here, we can actually observe that 10 plus 1 is equal to 11, which is greater than 9. Since the array is sorted, right, so we don't need to check more elements that are to the right of our jth index, because it will end up being more than 9 anyways. Okay, so in the next iteration we would basically move I forward and keep doing the same thing. So in the next iteration I would come here, j would come here, and we just keep comparing this way, so on. So this is certainly, I mean, from brute force or naked eye approach, it the time complexity in the worst possible sense is O of n square, which is certainly not good enough for any of the interviews. And let's try to optimize it further. Optimization. So one of the hints that the question gives us is that the array is sorted. So whenever it's mentioned as sorting or sorted in the question, 99% of the times is going to be a binary search approach. But the trick is how we are going to approach this, right? So in this case, now let's say this is like a 1% chance that it's not. In this case, it's a two-pointer solution. Okay, so we actually don't need binary search for anything in here. So we can just do a basic two-pointer approach, and let us see why we actually need two pointers. So as you can observe here, right, we keep our eye moving in the outer loop, and in the inner loop, when we move j, we keep moving j until we come to a position where I plus j is greater than the target. So until then, j keeps on moving. So our sum, basically, I plus j, is constrained by the value of j. So at some point of time, when the sum becomes greater than the target because of the j value, we stop moving further. And hence, when j, the conditions for j are reached or breached, we even stop moving I further. So that gives us a clue that we can do one thing, right? So if I again copy this array here, instead of having our jth index here, okay, and ith index here, let us keep I at the same place. Let us start it from here, but I would start j from here. Okay, I would start j from the last element, which is the largest, and keep decreasing it, now bringing it inwards until we find a solution. So now the question is, how do we know which uh, pointer to move, right? So this is a I mean really easy intuition to get. So if our I plus j value, as in here it's 1 plus 11, which is 12, that's greater than 9. So in this case, our sum should reduce, right? How do we reduce it? So if we increase, let's say, if I increases, okay, so if we move I here, now the sum would be 11 plus 3, which is 14. Plus 3, that is 14, which is greater than the previous sum that we got here, 12, and obviously it's greater than 9, which is our target. So certainly we cannot move I. What's the only possible thing that we can do? That is move j inwards. Okay. In this case, if I move j here, now the sum would become 10 plus 1, that is equal to 11. Now this is less than 12, which was our previous sum, and it's still greater than 9, but at least this particular condition that it's less than our previous sum has satisfied. So the sum is decreasing, which is what we want. So the conclusion is, let's get j inwards. Okay, j comes here. Now we again repeat the same thing. So let us check. Okay, I is equal to 1, j is equal to 10. Okay, I plus j is equal to 10. 1 plus 10, that is equal to 11. So now 11 is greater than 9. We need to decrease our sum. So we move j in further. So now j comes in further. Okay, so j moves here. Now we do the same thing. So I is equal to 1, j is equal to 7. Okay. In this case, we get the other case because 8 is less than 9. So we need to increase the sum. Hmm. I So now I would come here. Okay, and let's just iterate through so that you get an idea, even though you might have understood the intuition. Is equal to 3, j is equal to 7. So I plus j is equal to 3 plus 7, that is equal to 10, which is greater than 9. So j comes inwards. Ignore the ambulance noise outside, please. So now proceeding, I is equal to 3, j is equal to 5, I plus j is equal to 8, less than 9. So I moves, and we finally reach our answer I. So I is equal to 4, j is equal to 5, I plus j is equal to 4 plus 5, that is equal to 9, yeah, which is equal to our target. Since we've given that only there's only one pair which can add up to the target, so in our case the solution uh, or the indices would be 4 and 5, or rather the indices would be 3 comma 4, like I showed you before, because it's one index, right? So the index starts from 1 here, not from 0. So it's 1, 2, 3, 4, so 3 comma 4. Okay, so this was the explanation. Now let's quickly jump to the code. It's not much. So essentially we keep L and R as 0 and length of num is minus 1, while L is less than R. If both of them add to the target, we return L plus 1 comma R plus 1. If it's greater than the target, then we move R inside. And if it's less than the target, then we need to increase the sum. So we move L forward. And yeah, that's all for this video. I hope you understood, and let's meet in the next one. Thank you.